Welcome to this build session, Reduce Fraud and Improve Engagement using Microsoft Entra Verified ID. Us presenting are Sydney Morton and me, Chris Young. This is the agenda. Take your app to the next level. We're going to show you how you can supercharge your existing apps with Verified ID, an open standards-based way of reducing fraud and help desk cost, and unlock offers seamlessly with partners. We're thrilled to announce general availability of our wallet library for iOS and Android. With it, your mobile apps can issue and verify these standards-based credentials. We will share with you a preview of enabling safe and secure way to do face match so that you can be confident that the user presenting the credential is the same person we issued to the credentials to in the first place. We're on the same team as Azure Active Directory, and we help millions of businesses around the world to engage with their users, employees, and vendors. When we surveyed these enterprises, we discovered that 92% of them conduct common activities such as onboarding, securing access to apps, and help users when they run into issues. However, 82% of them wish that there was a better way because our current identity process rely on possession of username and passwords or FIDO keys, etc. to onboard and get access. When it comes to recovery, we can rely on poor practices like email and SMS round trip, or even worse, yet knowledge-based questions and asking what street did I grow up on. And given that that's just a search on the internet away, that's not really secure. We believe that there is a better way via open standards that you can create safer, faster, and easier way to configure remotely and issue credentials. So let's take a look at a demonstration of digital reality cards powered by open standards. And we then dive into how to bring these experiences into life in your app.
In this demonstration, we will show you how to leverage open standards with Microsoft Entra Verified ID. You'll be able to transform your app in 5 minutes to 1. Reduce the risk for fraud, 2. Reduce help desk costs, and 3. Unlock offers seamlessly with partners. Reducing fraud and account takeover risks. Here's how Northwind Airlines, a travel company, can supercharge their app in minutes. Today, users sign in using their existing credentials. But with just a few lines of code using Entra's new wallet library, Northwind Airlines' existing app can be updated to reward all of their users with a digitally verified loyalty card. Flyers can store this verified ID in their app, transforming their account into a digital wallet. Verified ID can be used to access services online and in person, such as access to airport lounges and in-flight purchase discounts, unlocking a whole new world of travel benefits. Reducing help desk costs. Another key challenge faced by most businesses is providing timely and cost-effective customer service. Northwind Airlines customers can use their verified ID along with privacy-respecting biometric FaceCheck to quickly verify their identity in real time, so that the help desk system can instantly pull all relevant user and trip context before first contact over chat or phone. Or in our case, approve a flight booking change and grant a travel voucher. Here, the user is awarded a travel voucher because their updated flight is cheaper, which they can add directly to their in-app wallet. This travel voucher is just another type of verified ID, which is as easy to redeem and use as the loyalty card. Unlocking offers with partners. Verified ID makes it possible to use the digital loyalty card to unlock offers with partners like hotel points, free rides, and discounted coffee. Since verified IDs are based on open standards, customers can use their digital loyalty cards anywhere, such as hotels, rideshare companies, or restaurants and cafes around the city. Boom, free coffee. With a few lines of code, your customers can unlock the doors to a whole new world of benefits and seamless experiences across the internet. To transform your app, get started by visiting aka.ms/verified loyalty cards.
So let's issue and present a digital reality card. We're going to do this in 3 steps. First, we're going to configure the look and feel of the card. Second, we're going to issue the digital reality card to the wallet. And third, we're going to present it and verify that it works. But first, let's see how the architecture looks like for this procedure. We have three components. On the left-hand side, we have the mobile app with a new version that understands verifiable credentials. In the middle, we have the backend, Northwind Airlines backend, an application that is using an identity provider. And on the right-hand side, we have Entra Verified ID service. The mobile app previously and continues to do so, authenticates to the identity provider. So Sydney Williams logs in the mobile app. What is new here is that not only does the mobile app access the backend to retrieve services and information, now it also can make a call and say, is issuance needed? Do I have a verified ID card in my wallet? And in this case, since this is the first time it's being used since the new version, the backend will realize, no, you don't. You don't have a card. And we need to talk to Entra Verified ID. We're going to make a request, an issuance request to Entra Verified ID and pass along claims from Sydney's user profile. Since the mobile app is authenticated and is making a protected call to Northwind Airlines backend, we can access Sydney's user profile from the identity provider. Northwind Airlines backend will pick up the claims that are going to be included in the verified ID card and pass them to Entra Verified ID service. Entra Verified ID is not going to store them or persist them. The only thing it does, it adds them to the issuance request. And the issuance request rolls back all the way to the wallet, to the mobile app, which makes a call back to Entra Verified ID to say, I'm going to issue a verified ID card to my mobile app wallet here. And Entra Verified ID returns it. So the mobile wallet is now armed with a verified ID card together with what it did before. So now that I've shown you this, how it works, it's time to hand over to my engineering partner, Sydney Morton, who can show you how to build this with code, with a wallet library. So welcome, Sydney.
Hi, my name is Sydney Morton. I lead the wallet library work and the verified ID integration work within the Authenticator app. Today, I want to take us all on a journey to configuring the digital loyalty card and implementing the feature of issuance and presentation within an existing Northwind Airlines app. Northwind Airlines wants to create a loyalty card for their users using verified IDs. The first step is to configure the look and feel for our digital loyalty card using the Entra portal. We can style the verified ID with accent colors, custom text, and a logo. We can also configure the source of claims contained within the verified ID. They can be transformed using existing credentials from any identity provider into a digital loyalty card that can be used in person and online across the internet. Now let's get down to the issuance logic. We have a file called loyalty card use case, which will be responsible for making calls to the wallet library. There are two functions, get loyalty card and present loyalty card. Let's implement the get loyalty card function first. We will use the verified ID client to create the request. And here's the rest of the logic that is needed. The request is an issuance request because we will use the token from the user session within the app to authenticate the user, we do not really need to do anything else but complete the request, and if all verification checks succeed, we will get back the loyalty card that is tied to the user from the Entra Verified ID issuance service. It looks like we're ready to test it out. I will start running the app, and I'm actually going to set a breakpoint right here so we can actually see the contents of the request. I'm going to sign into the app, and I'm going to press Get Loyalty Card. Here is the request for issuance. We have the style elements that we saw when we configured the look and feel of the verified ID. We also have the requirement needed to issue the verified ID. And we can see that there's a token here that we will use to pre-populate the claims within the verified ID. We also have this root of trust that just basically ensures that the initial request came from the Northwinds airline company. So let's go ahead and continue. Ta-da! We now have our loyalty card, and it is that easy to integrate the issuance of verified IDs within any existing app using OIDC compliant identity providers.
Presenting a digital loyalty card. How does it look like? What's the architecture? We have the three pieces here with the mobile app on the left-hand side, the relying party application, Northwin Airlines backend in this case, and Entra Verified ID services on the right-hand side. It all starts with a relying party application. Northwin Airlines here decides it's time to ask for a presentation. It makes a call to Entra Verified ID's APIs to say, I want to create a presentation request. The details here in the payload tells who am I asking for this, how can you contact me back, why am I asking for this, the holder needs to know that, and also the details, what am I asking for, Northwin Airlines in this case. Do I allow the VC to be revoked, etc. Entra Verified ID returns the presentation request that Northwin Airlines turns into a QR code. The user scans the QR code, sees the request, decides to consent to it and present the verifiable credential, submits it back to Entra Verified ID. At this point, Entra Verified ID sees the verifiable credential being submitted. It does a couple of checks to see, was it really issued by Northwin Airlines? Was it issued to this user? So the submission is actually correct. Does it match what was actually asked for? Because if you're asking for a Northwin Airlines credential and you're getting something else, it doesn't make sense. The wallet made some mistake. All these verification passes and Entra Verified ID after successful verification passes the claims of the VC back to the relying party application so they can see that presentation has happened and continue with whatever the business process contains after presentation. So with that, let's go back to Sydney, who can show us how to do this in code.
Next, let's look at how to request and present verified IDs to third parties like a help desk or airport lounge. Let's go back to the loyalty card use case. We will again use the verified ID client to create a request. Let me fill in the rest of the function. The requirement of a presentation request is a verified ID requirement, and we can fulfill it using the loyalty card. Lastly, we complete the request. The verified ID service will validate the verified ID is signed by a trusted issuer, has not been revoked, is the correct credential type, and passes a few other standard-based verification checks. Easy as that, the implementation is complete. Let's test it out. In this test scenario, the Airplane Museum is letting Northwind's loyalty members register early to an air show. To verify we are eligible, we need to present our Northwind loyalty card. Let's scan the QR code, which contains the verified ID request input, and complete the request. Yay! We are now registered, and the feature works end-to-end.
So now that Sydney has shown us how to code up a presentation, we will take it one step further. We will look into how you can do step-up verification using FaceCheck, the new FaceCheck feature that is in preview. What we're going to do next is we're going to request a biometric verification using the FaceCheck, and we're going to validate the response. Architecture overview of FaceCheck. How does it work? We have the three pieces that we've had for previous presentations, the mobile app on the left, the Northwin Airlines backend as the relying party application in the middle, and Entra Verified ID service on the right-hand side. Again, it all starts with the application deciding it's time to do a presentation request here. This time when it calls Entra Verified ID, it says it needs to be with FaceCheck, with a FaceCheck. In the JSON payload, you can see down below the added attributes. The Northwin Airlines specifies that we're going to use the claim name photo to match with the liveness check, and we want a confidence threshold score of 70. That's when we evaluate. The result from Entra Verified ID back to Northern Airlines backend results in it can present a QR code with a request that the mobile app scans. What happens now, besides selecting the appropriate verifiable credential that is being asked for, is that the camera is turned on after the user consents to it. And the mobile app does a liveness check where it asks the user to not be too far away, not too close, make some movements, etc., so we can see that it's a real person. When the mobile app is happy with the recording, it's time to present. And the mobile app presents it back to Entra Verified ID. What is being presented back is the selected verifiable credential and including the liveness data that was captured when the camera was on. What Entra Verified ID does next is matching the photo in the VC that was presented together with the liveness data that was provided to get a confidence score. Is this really a person? Does it match the photo? What is the confidence score here? After that is done, the normal verification to see the verifiable credential that was presented. Was it issued by Northern Airlines? Was it issued to you? Who's presenting it, etc.? Does it match what was really asked for? So we know that we got a valid presentation. After the verification has happened in Entra Verified ID, it again does the callback to the application. This time with the claims in the verifiable credential plus the score from the matching of the photo against the liveness data, the confidence score. It does not return the liveness data. The liveness data was just handed over from the mobile app to Entra Verified ID, where Entra Verified ID did the checking. It's not persisted, it's dropped, therefore. The backend then can decide, okay, if the confidence score was 75, good, I'll move on. We've had a face check that works. So now that we've seen this architecture overview, how it works, I'm going to give it back to Sydney so she can demo it, how it really works with the mobile app in her hand. So over to you, Sydney.
To add additional security to the presentation flow, we are partnering with Azure Cognitive Services team to bring FaceCheck as a safe, privacy-respecting way to ensure that the person presenting digital credentials is indeed the one to whom they were issued in the first place. For scenarios that weren't high insurance, such as changing a flight, apps can trigger a FaceCheck request in addition to presenting a digital loyalty card. To configure FaceCheck, simply add these two properties into the body of the presentation request to the request service API, and FaceCheck will be required. Let's see it in action. For this demo, Northwind is asking me to present my verified employee card with a required FaceCheck. I deep link from the browser to the app, and I see that I will need to verify my identity with FaceCheck. I scan my face and send the information to the request service API to do all of the validation. Once successful, my verified employee card containing my photo on my work badge and other attributes is shared with Northwind. My biometric data is not shared, just the confidence score that the face on my employee credential matched the biometric data from FaceCheck. And there you have it, step-up authentication through verified IDs and FaceCheck.
So that was a demo of FaceCheck by Sydney. Now we'll continue with roadmap and resources. But first, customer stories. You'll find them available at aka.ms, verified ones. We have UK Department of Education, who is using Verified ID for student IDs. Also within the UK, you have NHS, National Health Service, that uses Verified ID for doctor verification across different areas. RMIT and KO. RMIT is Royal Melbourne Institute of Technology. They also use Verified ID for student identities. We have Avanade, who is using Verified ID for collaboration scenarios to get within Avanade and together with Accenture. Agilus and Credivera, the use case there is labor union and members within the labor union. You have Launder which is the government of Flanders, and they're exploring using Verified ID to help citizens starting new businesses more easily. What's on the roadmap? Well, 3 things. You saw FaceCheck, and we demoed it using the Microsoft Authenticator. But on the roadmap is bringing FaceCheck capabilities onto the wallet library so you can do it there too. We're also looking into supporting up-and-coming standards. And one example of that is selective disclosure. So you can select which claims you decide to present to a verifier. So you don't present the entire set of claims that you have in a verified ID card. We also have support for additional formats and protocols. And additional formats could be e-passport, where you could enable scanning an e-passport and retrieving claims from it in the appropriate circumstances. And for protocols, it's things like NFC that can enable using getting presentation requests in other forms than scanning a QR code. Resources available. Here we have a list of 8. I'll highlight a few. If you want to go and see the developer documentation, how do I start with this? Number 4 is for you, aka.ms did for devs. It will take you to the public documentation where you can read all about how to get started with this. If you just want to test it using the authenticator with an existing app ready to go, number 7 is for you, aka MS did demo. It's a demo site, not the Northern Airlines that we used in this session, but it's a demo site where you can test the concept of verifiable credentials with verified ID. If you're interested in using the wallet library with your own applications, you should have a look at resource number 8, because it will take you to the GitHub repos for the wallet libraries. We have 2 here, one for iOS and one for Android, of course. So with that, we have come to an end to this session, Build 2023. Thank you so much for listening to us in this session, and we'll hope to see you again.
Thank you.